Hey guys, today we're going to talk about something called the vertex form of a quadratic. So we know how to write a quadratic in standard form. This is just a different form, and this one's a little bit easier to find the vertex of the parabola, which is why it's called vertex form, and it's easier to do different transformations, like moving parabolas around the coordinate plane and comparing parabolas in this form. So we'll go through this. So today we're going to talk about just how to graph in this form, but first I'm going to explain what the form is. So in the form, it's f of x equals, or y equals, and we have a times the quantity of x minus h all squared plus k. So in this form, we'll start with the h and the k. Like I said, it's easier to find the vertex in this form because it's going to be jumping out to you in this form. When you're in this form, your vertex is going to be h, comma k. The only thing you need to do with this is be really careful because it's going to be the h value, so it's whatever you're subtracting here. For example, if you had y equals x minus 3 squared plus 1, your vertex is going to be 3, comma 1, because you're subtracting 3. If it was plus 3, then this would be a minus 3 down here, because that would be like x minus negative 3 in there. So you have to be careful with the sign here. The k is nice because whatever the sign is in front of it, that'll be the sign of the vertex. The h is going to be the opposite of what you see in there. Okay, so that'll give you the vertex. It jumps out to you. There's a lot of other properties with this that we'll go into more detail tomorrow. Today I just want to talk about the a in front. The a in front is going to tell you a few things about the parabola. A, depending on the sign, if it's positive, so if a is greater than 1, or sorry, greater than 0, then you're going to open upward. And if a is less than 0, then you're going to open downward. So if it's negative, you're going to open downward. Just like the a in our standard form, it's going to indicate if you open upward or downward. And also, depending upon the value of a, so if a is a number like 1, actually we'll say greater than 1. So if a is greater than 1, numbers like 2, 3, 7.5, any of these values, it's going to make the parabola kind of get more narrow. So it'll look more like this. And if a was less than 1, but greater than 0, so like numbers like 1/2, 2/3, things like that, it's going to make the parabola get wider like this. And we'll see examples of this in our graphs today. So just by looking at these certain values in our form, we should know what to expect with the graph. So when we are graphing in this form, again, you're going to have the vertex given to you in this form, which is nice. So the first thing you're going to do is graph the vertex. And one thing we know about the vertex is the axis of symmetry is going to be x equals whatever your x value is. So in this form, you also have the axis of symmetry. So that's really nice as well. So you graph the vertex, you'll know the axis of symmetry, and then you just use different inputs and different inputs to find outputs, and then use symmetry to graph numerous points at a time because you know the axis of symmetry. So this gets you the center of the parabola a lot quicker. And then of course you're going to know what to expect with a. Should you open upward, downward, you're going to see it become more narrow or become wider. So let's go ahead and jump into one of these. So our first one that we're going to graph using vertex form is f of x equals 2 times the quantity x minus 3 minus 8. So notice that we are in vertex form. So right away we should be able to pull out. The vertex is going to be, we're subtracting 3, so it's going to be 3, negative 8. That's going to be our vertex, which means our axis of symmetry is going to be x equals 3. Looking at the a value, it's 2, so the a value is positive, so we should expect it to open upward. And 2 is greater than 1, so it's going to make it a little more narrow because it's going to change increasingly, like at a higher rate. So first thing we're going to do with this, take our vertex, 3, negative 8. So we're going to go 3, negative 2, 4, 6, 8. So right here's our vertex. And we know the axis of symmetry was x equals 3. So we're going to be symmetric over this right here. We know that we should be opening upward. So the best thing to do after this is now find some other points. I like to make a little table. X and your, in this case, f of x. We had 3 and negative 8. That's going to be our axis of symmetry, so our vertex. So I'm going to use points that are really close to it. Like if I use 4 going 1 higher, then 2 going 1 lower, they're both going to have the same output. They're both going to be the same distance away from that axis of symmetry. So if you put 4 into this function, I'll do it over here, f of 4, you're going to have 2 times 4 minus 3 is 1 squared minus 8. So f of 4 is going to be 1 squared is 2, or sorry, 1 squared is 1 times 2 is 2, minus 8 is minus 6. So since 4 is negative 6, 2 is also going to be negative 6. Because when we go to the graph, we go to 4 is negative 2, 4, 6. Negative 6 will end up being the output for 2 as well because they're the same distance from that axis of symmetry. And then I would just continue. Since we did 4 and 2, let's just do 5, and then 1 in the other direction would be 1. So if you put f of 5 into the function, you're going to have 2 times 5 minus 3 is 2. So 2 times 2 squared minus 8. So f of 5 is going to be 2 times 2 squared is going to be 2 times 4 minus 8. So f of 5 should equal 0. And we'll end up with 0. If you had put 1 in here, you would have ended up with 1 minus 3. So it would have been negative 2 squared, which ends up being positive 4 anyway. That's why they're going to have the same output here. So we're going to go ahead and say at 5, 1, 2, 3, 4, 5, we get 0. And at 1, we should also get 0. So there's our, we have 5 good points here. So now we just use that smooth curve. That's the parabola. And it should look something like this. So there we go, graphed in vertex form. Notice that the A was 2 here, and this parabola is kind of a little more narrow. That just means it's increasing faster, and it's because you're multiplying by 2, which is going to make you change a little faster. So let's go ahead and try another one. Our next one, we have, take all this away. We have the function f of x equals 1/3 x plus 6 all squared minus 1. So again, first thing you want to look for, get that vertex. It's going to be minus 6 comma minus 1. And that means your axis of symmetry is going to be x equals negative 6. So I'm going to go ahead and graph that right on here. Negative 6, 2, 4, 6, negative 1. That's our vertex. Looking at the A, it's positive, so we should open upward. It's one of those values that's less than 1 though, so it's going to become like a wider parabola, meaning it's not going to be as narrow as the other, it's going to be wide. We'll see what that looks like. But we know this is our axis of symmetry, and we know that we're going to open upward. So let's find some other points here. So we have, I'll make a little table. We have x and f of x. We know that negative 6, negative 1. So we can put in some other values here. So let's say we tried to do negative 7, then we would have negative 5 here. If we were to put in negative 7, we're going to end up with 1 squared. Or sorry, negative 1 squared times the 1/3. So we're going to have 1 times 1/3. So if we do f of negative 7, we're going to have negative 1 squared, which is 1. 1 times 1/3 is 1/3 minus 1. So f of negative 7 is equal to negative 2/3. If you want to try to set things up so that you're not going to have fractions like this, you need to choose values inside here that are going to end up, after you square them, being a multiple of 3. So numbers like Well, when you square 3, you'll end up with 9. When you square something like 6, you'll end up with 36. Try to think of values that you're going to, when you square them, end up with multiples of 3. But since we have this, we'll stick with this for now, and we'll do our best at graphing. So -7 gives us -2/3. -5 will give us -2/3 as well because of that symmetry. So -7, which is 1 over, will be -2/3. It's about right here. Same thing for -5. And let's say we put in, let's keep going, we'll say x is, let's try to find a number that's going to be nice for us. So let's do, x is going to be -9. Since this was like our center point here, that's our vertex, we're 3 away, so in the other direction I'm going to go 3 away. That way we'll have the same output. So f of -9, when you put -9 in here, you end up with 1/3 times -3 squared minus 1. -3 squared is 9 times 1/3, so 9 times 1/3 is going to give you 3 minus 1. So f of -9 is going to equal 2. And if you were to have put a 3 in here instead, you'd end up with 3 squared, which is 9 times 1/3, which is 3 minus 1. You're still going to get the 2. So when we have -9 and -3, so -1, 2, 3, we have an output of 2, let's see, 6, 7, 8, 9, output of 2. And if you look at our parabola, like I said before, it's going to become wider, and this is what I mean by wider. The other one became more steep, where it was going more up and down. This one's going a little bit wider. That's because you're multiplying everything by 1/3, so you're not going to change it as increasing, but you still are going to go up in that quadratic form. Alright, on to our last one of how to graph with these. In this one, we have the function f of x is equal to -2 times the quantity x minus 4, all squared plus 5. So first thing you want to pull out here is that vertex. Your vertex is going to be 4, 5, which means our axis of symmetry is going to be x equals 4. So when we go in graph, we go 4, 5. We're right here. Axis of symmetry is going to be right there. So we're going to be symmetric over that. Our a is a negative, so we should be expecting it to open downward. And since it's a 2, like if you took the absolute value of the a, it's 2, then that means it's going to be more narrow graph. So we should be expecting it to be more narrow. So let's go ahead and I'll make a little table here. X and, we don't have y, we have f of x. So we had 4 and 5. That was our middle, so let's go with 5 and 3. When you put a 5 in here, you have f of 5 is going to be -2 times 1 squared plus 5. So f of 5 would be -2 plus 5 is +3. So 5 and 3 will have the same output of 3. So let's see, 4, 5, output of 3. Same thing for 3. And let's say we continue and we go with 6 and 2. When you put a 6 in here, you're going to end up with -2 times 6 minus 4 is 2. And you're going to square that, plus 5. So f of 6 would be 2 squared is 4, times -2 is -8, plus 5. So f of 6 should be -3. So we have -3, we have -3 for 2. That's because of our symmetry. So 6 goes down to -3. Use your symmetry. That's where the 2 is going to be, -3 as well. And this will be your parabola, for what we had. Make sure you add the arrows at the end, and we're all done. So for this function here, our parabola is right here. Some of the key things to keep in mind with this, we like this form again because of the vertex that you can pull right out. Just make sure your sign is correct with the x. Big mistake that people make that you should not make is right here. This is not the y-intercept. So this is not y-intercept, because you would end up multiplying. You're going to have other constants that you would add to that. So this is not the y-intercept. Don't make that mistake. In standard form, the c at the end is. Here, that's not like the c value. That's why we have it a different variable. It's k. So don't mistake that for the y-intercept. We like this form again. That vertex comes right out for us. All right, so go ahead and try some of these on your own. Have a nice day.